Hello, it's me, Mike again, and in this video we're going to continue with our limiting reactant question from our last video. So if you have not watched the last video, it would definitely be helpful because in the last video we were able to determine this first part right here. We were able to determine the limiting reactant, and we also, even though it didn't specifically say, we were able to determine the balanced reaction. So we needed the balanced reaction in order to determine the limiting reactant, and that's what we have here. And then via our calculations, we were able to determine that oxygen, molecular oxygen, this guy right here is in fact our limiting reactant, which will then allow us to continue on with our second part of this video. So it's going to be this part 2 portion right here, where we are asked to determine the mass of carbon dioxide produced by the reaction in the above problem. So we want to know how much carbon dioxide, which is this guy right here, is produced when we react this C2H6 with the molecular oxygen. So in order for us to do that, we must always use the mass of the limiting reactant. So I'm going to write that down here because I think that's very important. Always use the mass of the limiting reactant to determine any values of the products. We could be asked to find the mass of carbon dioxide produced. You could be asked to find the mass of water produced. You could be asked to determine the moles of carbon dioxide produced or the moles of water produced. Whatever we want to determine anything that's produced, we always start by using the mass of the limiting reactant. So here we are given the mass of the limiting reactant that we started with to be 94.0 grams of oxygen. So I'm going to go ahead and start with 94.0 grams of molecular oxygen, which is O2. Remember, we're always going to have to go from mass into moles. We always want to convert to moles because moles allow us to relate everything unique about our stoichiometry. So now if we want to go from grams to moles, we look at the molar mass of O2, and that's given the problem. It's not as exact as I would like it, but this problem is not really all about determining the molecular mass. It's actually determining limiting reactants, so they want to make it easy for the steps to be performed. So we're just going to use 32.0 grams per mole. So we're going to multiply this times 1 mole of O2 per every 32.0 grams of O2. And I did that because this shows that the grams of O2 cancel with the grams of O2, and right now we're left in moles of O2. But remember, in this question, we want to determine the mass of CO2 produced. So we want to go from O2 into CO2, specifically grams. And here's where we're going to use those stoichiometric coefficients of 7 and 4, because we know that 7 moles of O2 are required to produce 4 moles of CO2. So that's going to be our next step. We are going to use the fact that we know we need 4 moles of CO2 per every 7 moles of O2. We're going to use that relationship. But again, we could have inverted this, but if we inverted it, then our moles of CO2 would not have, when our moles of O2 would not have canceled, and we're no longer going to be in moles of CO2, which is what we want. Because now from moles of CO2, we can use our molecular weight of CO2 in order to calculate the mass of CO2 produced, which I know is a mouthful to say, but we can always go from moles back to grams by using the molecular weight. So we know that the molecular weight of the CO2 is actually given in this question. It's going to be 44.0 grams per mole. So we're going to multiply this times 44.0 grams of CO2 per every 1 mole of CO2. And notice what happens here is that now our moles of CO2 cancel moles of CO2. We're going to be left in grams of CO2, which is what this question wanted us to determine. So we know that we have the correct computations. We just have to go ahead and execute them using our calculator. So I'm going to go ahead and pull my calculator down here to make sure that we all know how to use this. So hopefully we can all see the calculator. So I'm going to go ahead and show us that we're going to start with 94.0, oops, 0.0, don't make that mistake, times 1, so I'm going to say times 1, hit enter. I'm going to divide this by 32.0, but that's the same thing as 32 on the calculator. We're going to multiply this times 4 and hit enter. We're going to then divide that whole value by 7 and hit enter. And then lastly, multiply times 44.0. And when I multiply by 44.0, I'm left with 73.857. I'm going to write all of that out. 73.857. So, 73.857, and they're going to evaluate sig figs afterwards, grams of CO2. So we recognize here that I started off with 94.0, and this has 3 sig figs. All the rest of these are going to be infinite amount. They all have infinite amount of sig figs. We don't use them to calculate sig figs. So since we started with 3 sig figs, we know we have to end with 3 sig figs. So we're going to cut this off right here. And we recognize that at the end, we are going to have 73.9 grams of CO2 produced. Remember, this question could have also asked you to determine the amount or the mass of the water produced. So we could have actually been able to determine from our limiting reactant the mass of the water produced. And in that circumstance, you would have recognized that there's 7 moles of O2 used to produce 6 moles of CO2. So that would have changed this relationship right here. It would have changed this relationship right here, and then you would have used the molar mass in order to calculate the mass of water produced. So even though in this question, it gave you the molecular weight of H2O, that wasn't really needed. And this happens a lot of times in chemistry, where they give you an extra amount of information to really make sure that you understand whether or whether or not you need it. So we finished up calculating the mass of CO2 produced, and in the next video, we're going to talk about how to determine the mass of the excess reagent that remains after the reaction took place. So pay attention to the specifics in these questions. Make sure to do and practice these questions out many, many times so you understand the process and you become very fluent in what you're using. Don't just memorize it. Try your best to understand why you're multiplying through by every single step.